So we can go in and basically start looking at nim itself. Like I mentioned, nim is statically typed, compiled. In this case, they say systems programming language. I think it's more just general programming language. And it looks a bit like Python. I never touched add-on Modula, so I can't say anything about that. And what I like about it is that native dependency-free executables, so they're small, no virtual machines, so that's already some boxes checked out for me. It supports, all the major platforms, so I'm good with that. I only worry about Linux right now, but it wouldn't hurt if, whatever I write will work on Mac OS or Windows. That would be cool. Memory management is basically garbage collected, so I don't have to do crazy stuff like in C++, remembering to delete variables or Rust, or even things like in Zig where it's overly verbose. It's relatively modern. You have iterators, you have many nice fancy things. So we'll go over that. And what is very interesting about nim is that the compiler doesn't compile the language itself directly into code. It first generates C or C++ or JavaScript, which is crazy. There's a difference that, whenever you're targeting C or C++ or JavaScript, between those two worlds, some features will work a little bit differently. But in my case, I only worry about C or C++. I don't want to write front ends in nim right now, at least. So it compiles to C or C++, and because how the thing with C and C++ is that they can run basically anywhere. You can, you have compilers for C and C++ that can target pretty much anything. You can target your, normal Linux or Windows machine, but nothing is stopping you to target, for example, ESP32 microcontrollers. And because of that, because nim actually first compiles to C or C++, there are actually libraries and project setups that allow you to target Arduinos. In this case, ESP32. I don't know if somebody's actually working with Arduino. That might be a little bit too low level. But that's the first thing. And the second thing is, because it just compiles to C, C++, it's just fast. It's really fast. In my case, as fast as you can go without, putting too much time into learning C, C++ to optimize things crazily. So, yep, that's something that makes me very happy as well. And it has powerful macro system. I looked a little bit at it, start getting a headache, but I guess if I would learn the language enough first, it could be very useful. And also has some template system, which is much nicer. You have the other nice thing that you have type inference. It's relatively smart to the point that you don't have to explicitly type everything. A lot will be figured out for you. So if you use TypeScript, for example, or even in some extent, if you use C# by using the var keyword, things are inferred for you. So you can write your code, and if you need to change something from int to long, it's often that you don't need to adjust too much. And just like in Python, statements are grouped by indentation. So let's look at their example. Let's see what they have here. So if we look at the example, import std/string format. That looks simple. It looks like we have a type declaration. Type person, that's an object. I presume this is similar to a class or JavaScript object. And it looks like we have two fields in there. Name, we can define as a string, and age, which is natural. Ensures the age is positive. So that's interesting. Usually we have just integer or float or something. Here we have actually, I presume it's an integer, just from 0 to up because it's a natural rule, so we can't have negative ones. So instead of saying uint, we just have natural. And so that was our type definition. And then we do let people. So let, I presume, is like in JavaScript, where you can create a variable named people. And it looks like it's an array of persons. So we can instantiate the person just by typing the name, and in parentheses, we just provide the data. And that's it. We have an array of people, persons. And then we have a basic loop. So for person people, that's easy. And type, save string interpolation, availability, compile time. So we basically echo is like print line or write line, and we format it. Okay, so our quotations are preceded by FMT. So I guess that makes it special. And we just insert person from our person name and age. And they say it's type save string interpolation. So I guess if I would try to put something that's not convertible to string, it would complain. And because it's evaluated at compile time, you don't have that situation where your code gets to that point and needs to go through the whole string and then do the whole interpolation on the go. Your compiler will probably compile it to person.name plus is plus age plus years old, and therefore you will get optimized code rather than trying to parse the template while during runtime. So I like that. Thanks to the iterator and yield constructs, iterators are easy to write as ordinary functions. They're compiled into inline loops. Oh, interesting. So we can iterators is, I think, in JavaScript it might be called generators. It's in C# there are enumerables. So basically it's a function that in this case looks like it takes two generic types. So we provide an A, which would be an array. Oh, interesting. In many languages, if you specify it that way, it would mean that it's a 2D array, but I think it means that you can specify the type of the index of array. That is very interesting. So we basically provide the thing with an array of t, and we just get t back. Interesting. Looks like just one t. Okay. Oh, because iterator means that if we'll give it a list, in this case, it will start iterating over the list. And only when it's an odd number, it returns that number. And that yield means that, hey, it's not an end of the function yet, or end, it's not return, it just returns that value. And whenever you request a next from that odd number, it will go back up. I need to go back to my loop and loops again until another one goes to yield, until you basically run out of items in an array, and then it finishes basically. So that means that you can use it in your for loop. So you can do for loop for odd and odd numbers, and you provide it with lists. So this will basically one by one be returning only the ones that are odd, and you can echo them. So that's very nice. This way you should be also able to do some fancy lazy loading things from databases where, let's say, you fetch in chunks and you return one by one, and whenever you next one, the odd numbers will take care of getting the data from the database. So you could just iterate over the records, even though in the background it might be, prefetching them asynchronously or whatever. I presume that will be possible in this language. So use NIM's macro system to transform dense data-centric description of x86 instructions into lookup tables that are used by assemblers and JIT, just-in-time compilers. Interesting. So we create a macro, we get some data, return untyped is what I'm saying. It's a, what do I say? Macros are interesting, but yeah, I guess look at the table of some instructions. Great. I'll ignore that. I don't want to go to the level of macros right now, nor assembler. That's not what I'm concerned about now. A simple example. Let's look at if-else case switch. So we have, wait, previously we had let, and now we have var. That's interesting. So we have variable conditional 42. So I guess it automatically figures out, okay, this is a number, probably integer. And if conditional is less than 0, we say this. Else if, so this is basically Python. I didn't do a lot in Python. I did some years ago, but okay, that looks decent. Nothing crazy here. Simple, I like that. And ternary, awesome. Oh, and if conditional is this, then true, else that. So ternary is, I like it, instead of just question mark and colon, you just have if and else. That's simple. Then we have another, and oh, cool. So the classic thing is with if else is that, you know, it's a statement that does something. While here it's used as an expression. So we say that another equals, and then basically this whole thing is being evaluated and shoved into another. So basically here we can use if, elif, and else as an expression, just like a ternary expression is. So that's really cool. I wonder what else can be used as an expression. In case switch, we create a letter, and we have single quotes versus double quotes. So usually single quote means that it's not a string, it's a character. So we have a character letter, and it's a switch statement. Here just they call it case letter of A. So if it's A to this, of B comma C. So we have basically OR. Interesting. I wonder if you can describe something more complex like this and that. Interesting. I wonder what the pattern matching capabilities are here. Okay, looks like a range. So the letter is between D and H. So looks like we can convert the character to a number, like an ASCII character to a number, and between this and that. Why not? That's cool. And of course else. So your default case. Cool, I like that. That's simple. Basic math. Okay, so we have some math package. Okay, this is all normal. Division. Oh, that's interesting. So if you have integers and divide them with normal slash, you will get a float, some kind of floating point. While if you want division on integers, you need to use div. Power is with, I have no idea what that symbol is. I just use it for power actually. We have modulo. Okay, all this stuff, p and tau, so we have some constant declared, and our functions from math. So that's all normal. Greatest common divisor, cool. So we have lots of goodies there. Okay, lots of good stuff. That's nice. Here's a range. Oh, that's very interesting. When you clamp the number of 1.4, you can actually use a range from this to that. And looks like it's inclusive, so it includes the 1.0. Okay, that's cool. I like it. Next we have string operations. Ah, okay, so we use ampersand for concatenating strings. Okay. Strip is to trim things. You can parse it to integer. Interesting, so you get a number, dot, parse to int. So you have basically something that's a string. You have some operations declared on that string. Parse floats, hexen, all that stuff, boolean and such. You have repeat. That's nice. You can check if it starts with something, if it ends with something. Okay. And you can join an array of strings. That's cool. It's all simple. I wonder if you can define more, like provide it with some kind of separator. or whatever we call it, delimiter, separator, let's say. You can find which index the C is at. You can count specific substring. Cool. Normalize. That's interesting. I wonder what that's defined as. And what else? We can split things with a separator. Oh, that's cool. We can center and indent. I guess when you're making some terminal, like CLIs or something, that would be handy. And an indent. Cool. I like it. Forward and tokenize. Okay, so I guess this will split it into words, just one simple function. I like that those things are already defined and, taken care of for different edge cases for you. One less thing to have to write on your own. And what else? We have scan tuple. Okay, year, month, and day. So we're basically destructuring a tuple. And by scan tuple, that's interesting. So I guess it extracts values from here depending on some kind of expression. Okay. That might be very handy, actually. Cool. What else is there? Comprehensions. So we can import multiple things, multiple libraries from the standard library. Okay, I like that. So variable collect new string, but new string, new sequence. For items, and that add symbol is interesting here. Oh, this is a colon. Okay, so, oh, I think I know what is happening here. So I presume this is maybe a constructor for a new sequence or something. Sequence would be like a list, I presume. So we can then use collect, and what it will like run this code. So this would be like your lambda in here. Usually, like arrow function or something. But instead you just indent it because you start a block here. And so basically we take this, let's call it a sequence. I presume that's what add is in front. So it's not an array, it's a sequence. And for each item we double it. And as this doesn't have any return or something, I guess that automatically returns it, just like you have in Rust. And therefore, that will basically collect it and add each element to that new sequence. Okay, that's definitely something you would need to get used to, but simple enough. Yeah, exactly. So it looks like that's a sequence of all those values doubled. Makes sense. What else do we have here? Again, collect table and key value, and not sure about that here. Maybe that's a separator here. I'm not sure. Possibly we just, this looks like we're getting a sequence of those three numbers. We iterate over them, but we get the key as an index, 0, 1, 2, and value, which will be 0, 5, 9. And then we basically convert it into pairs of that key and value divided by 2. So in this case, because we're using the division for integers, they will stay integers. So it will be probably 0 and 2 and 4. And therefore, yes, we have index 0 and 2 and 4. Yep, and not sure what that is exactly, because then we're calling to table for some reason. So I guess this becomes a table while this is, I'm not sure what this is. Okay, we also can do again this collect thing and a hash set for item and make a list of elements, unless that plus symbol again means something else. I don't know, a little bit confusing. I guess we'll get to that. And then we have to sequence 1 to 15 and map it. Oh, okay. So if it's divisible by 15, we have fizzbuzz. If the item in the sequence is divisible by 5, we do this, 3 fizz. And if not, just leave the element as it was, whatever that $sign is. Maybe converts it to string, because we're returning strings here while we, as input, we're getting numbers. So I guess this will be interesting to just put a $sign to convert something to the string. Okay, and then we join with a separator. Okay. And remove all the white space. Yep. I really like that. You can map it and can create sequence of a range. Awesome. I like those little goodies. Okay, so that's basically introduction to Nim. Let's see if there is some tutorials or something. Go to documentation.